Let's answer what is a system of equations. It's pretty easy. Just take two or more equations and you have a system. So the particular one I have on the screen is a linear system. How do I know that? Because they're both lines. So think about what could happen if I have two lines. Well, it's possible that the lines intersect somewhere in the coordinate plane. This would have one solution. And that solution would be the point where the two lines intersect. It's also possible that I have two parallel lines. So if you think about, well, where would two parallel lines intersect? They're never going to. So this would have no solution. And then a third scenario might be that I have a line and then the second line happens to fall directly on top of the first line. These would be known as coinciding lines. So how many points do they have in common? Well, every single point on that line is a solution, so this has infinite solutions. So what we're going to do is, just if I give you a system, can you determine which of the ordered pairs is a solution? The easiest way to do this is to substitute and let your calculator do all the work. So I'm going to start by testing the point -2, 3 right here. So I'm going to kind of do this in an ordered format where I take my first equation here, y equals -x minus 5, and I'm going to plug in. Please remember that ordered pairs, the x is first. So when I do this, all I did was I opened up parentheses in place of the x, and now I'm going to plug in here. I'm going to switch colors to make this easier on your eyes. So the x is -2, and the y is +3. So on the right side, this is read as the opposite of -2 minus 5. You can type this whole thing into your calculator. This would be equal to -3. Does 3 equal -3? No way. So what that tells me is this isn't not a solution, or more importantly, it's not even on the first line. So if it's not on the first line, I don't even care if it's on the second line because it couldn't possibly be on both. So now I'm going to test the second point. I'm going to plug in -1 for y, and I'm checking, does that equal the opposite? And let me switch colors to show you the ones I'm plugging in. I'm plugging in -1 and then -4 over here for the x. So does -1 equal, type this in the calculator, the opposite of -4 is 4, minus 5 is -1. This one works, but I'm not positive it's a solution to the system. What I need to do is take my second equation, the -6x minus 5y, and plug it in there and see if it fits. So when I do that, I'm going to plug in the x is -4 and the y is -1, and I'm going to type this side into the calculator and see if it equals +27. When I do that, I get 24 plus 5 is 29. No way. Doesn't equal it. So what's that tell me? I'm going to cross this one off. It's not the solution. Now, I've kind of done this problem in advance, and I'm going to take a look at this last one here, just for sake of space on my screen. I'm going to test this one. So I'm going to plug in -3 equals, plugging it into the first one, the opposite of -2 minus 5. This would be -3. So it works in the first one. Now I have to verify that it works in the second one. So I take the second equation, -6x minus 5y, and I'm checking, does that equal 27? So I plug in -2 and -3. This would be 12 plus 15, but again, just type that whole thing in your calculator, let it do all the thinking, and I get 27 equals 27. So my conclusion is that -2, -3, this ordered pair right here, is the solution to the system. So if I would graph these lines in the coordinate plane, which we'll eventually do, I would see, just a quick little sketch here, that in the coordinate plane, I'm going to have two lines that intersect at the point -2, -3. All right, there's a very brief scenario on how to check to see if an ordered pair is a solution to a system of equations.